slides, right? But when we go into the depth, so basically, first of all, we talked about the EC2 instances, right? Or we can say servers, where we deployed our application, where we build our application, or where we are keeping the web server and that kind of stuff. Okay, servers. Now, when we talk about the older approach, in which we were deploying the application directly on a server, the single application. Like for example, I have an application built on Python, okay, and I'm deploying this application directly on the server. Now, as you guys know, like every application has few components. Components means the parts of the application: front end, back end, database, and if there is some any middleware API for the communication of these stuff. So every application has few backends, right? So when it comes to the about the backends, managing backends on one server, or you can say when it comes to the components, managing components on a one server, it's not a good approach. Why it's not a good approach? Because, for example, due to some issue, middleware APIs are not working. Okay, or due to some issue, this server goes down. What will happen? The whole application will be down, right? But what if we divide every component in a separate server? What will happen there? If one component is down, the services or the dependency on another component will not work definitely. But if there is a component which is not dependent to that down component, that means that component will be working absolutely fine. Okay. So for example, front end is not dependent on middleware API because it's just showing the UI concept. So what will happen there? If middleware API is down, there will be no impact on front end if the both components are deployed on separate server. You guys know, got it? Or you guys can understand it like the isolation. Like in COVID, what we did, we isolated the person who is suffering from COVID into a separate space. That's how we were preventing from the spread of COVID, right? The viral. So it's the same thing. If the one person is infected, it will not infect the another person if that person is isolated. The same thing we can do with these applications. If one component is affected, the only dependency, like for example, there is one component, like if we talk about the database, the backend communicates with the database, right? They both are dependent to each other. Whenever there is a request of getting the data, inserting data, the request goes to the database through the backend. Now, due to some issue, database is down. The backend will be down, right? Because the backend will not be able to send the request to the database, but not the whole backend. Few part will be functional, few part will be down. If both are deployed on separate server, not on single server. When we talk about the single server, if there is any impact on single server, if the single server, the whole server is down, whole application will be down, right? Because everything is deployed on the same server. In this scenario, because we want to deploy every application, every component on a separate thing, if I launch 4 servers, what do you guys think? Is it a good approach to launch 4 servers? Basically, yes, we can do that. It's not that much difficult. If you want to deploy application on multiple servers, we can do that. But again, we are using 4 servers. Means we have increased the demand of infra. Like we have increased the infra. So the cost will be increased, right? Because we are deploying every component on a separate server. The cost will also increase. So from the cost point of view, it's not a good approach. It doesn't seem that good, right? So first of all, let's don't talk about not talk about the cost. When we talk about this only, deploying application on different server, like for example, backend is here, DB is here, and MD API, middleware API is here. Okay, and front end is on this server. So this approach is known as the microservice approach. Why microservice? Because we have divided application in multiple components. Now, again, it's not a completely microservice approach because what happens in the microservice architecture, most of the backend is divided into APIs. Now, why the backend is divided into APIs? Because it's a basically concept of developers. Usually, what happens whenever a developer is writing the code, from the old approach, they write the whole code once in a single file. So this is not a monolithic concept, right? When it comes to the microservice concept, the code is written into multiple subcomponents, like backend for backend communication to the front end, backend for the database, backend for the middleware API. It's divided into multiple components. Only backend will be divided into multiple components. I mean, so same as front end can have multiple separations, database will be single, or yeah, most of the times database is single. But when we talk about the APIs, we have multiple APIs as well. So from the developer point of view, the developer will write the code into multiple subcomponents like these components, and those components will communicate with each other. Okay. So this approach is known as microservice approach, where we have the separation of application into multiple components, small components. That's why the word micro is over there. Now, when we talk about the monolithic concept, monolithic means everything is on a one page or one side. Like this approach, where we are deploying every whole application on one server for the DevOps point of view, as well as where the developer is writing whole code in one single file or in one single component. That's the monolithic approach. So here we have two point of views to see the monolithic and microservice approach. Point one, you can say point of view from DevOps side. Second point of view is from developer side. From the developer side, the everything depends on the code base, right? How to write the code in single file or single component or in multiple components. From the developer DevOps side, this application should be deployed into multiple servers. Every component should be deployed into a different server, so that they cannot impact to any other component, right? So this is the major difference between monolithic and microservice architecture. You guys got the concept?
Yes.
Okay. Now, just after this monolithic and microservice architectures, like when we talk about the microservice, the word containers was introduced. Now, why there is a need of container? Because as I told you, like we can do this, launch these servers, right? And we can do our work properly. But remember, every time whenever a feature is implemented in DevOps or the operations side, it's not necessary that it's only for the operations team or the DevOps part. Sometimes the benefits are also related to the developers. Okay. Why? Because if we talk about the DevOps, what is DevOps? DevOps is development and operations. So you have to talk about development here as well. That's why I am clearing the development part here as well, like the work of developers that they do in the terms of microservice. Okay, you should know like how the application is divided into multiple components and how you are going to deploy it on a microservice architecture. Now, when we talk about the containerization, so initially when we talk about this concept, number one, we have a concept of virtual machines. You guys know about virtual machines? In short, we call them VM.
Oh, know about virtual machines as in, what do you mean? Are you talking about the concept of virtualization or just a virtual
Exactly,
machine?
exactly. Virtualization, the concept of virtualization by which you launch virtual machines. Okay.
Yes.
So what happens there? Like in AWS, the same concept is happening. We have a data center server or a hardware server. We have installed a low-level operating system or a hypervisor over there on that operating system, low-level operating system or hypervisor. We have divided the server into multiple sections, or you can say multiple parts. And we are using each part to deploy the application or to managing the things. This is how virtualization works. Now, for our system, for the local system, like I have one system here, one software here, which is VMware Workstation. It's also a tool which provides you the virtualization, okay, kind of hypervisor in which I can install the operating system over the host operating system. So host is Windows 10, which is running in the background. And over the Windows 10, I have installed this Ubuntu operating system, which is my guest operating system. So this is how virtualization works. And we can install multiple operating systems in this environment as well. Now what's happening here, if you guys go here and go to settings, what I have did here is, let me show you the settings. I have given this 4 gigabytes of RAM. I can give it up to 16 gigabytes of RAM. As you can see, this is the maximum RAM that I have available in my system. I have provided 4 processors here, and you can increase the number of processors as well if you have available processors or available cores. Also, the hard drive is 20 gigabytes. It's a flexible hard drive. Depending on the requirement, the hard drive will be increased and decreased. This is the CD drive, which is actually the image of Ubuntu, which is mounted to this system. Then we have the network connection. That means I have created a virtual environment for this specific other Ubuntu system, right? That's why I'm able to use this like here. Okay, so two systems. This is also a GUI system, right? You guys can see this is the graphical user interface system. Two systems installed in one, you can say, base machine. Two OS and one base machine. One is host and another is guest. So this is how virtualization looks like. The same concept. But here I'm using VMware on that point when we talk about the on-premises, where we have the guest OS as a Linux operating system. Sorry, host OS as a Linux operating system, and we don't have GUI, like graphical user interface is not there. In that case, you use the KVM most of the times. It's also a tool for the Linux systems where you have the base operating system is the Linux and you want to perform the virtualization. Using KVM, you can divide the machines or you can create the machines. And when we talk about the data centers, so in the data centers, we may have the hypervisor. Okay, hypervisor programs, which are not the whole OS, they are not OS, they directly divide the system or the hardware into virtual separate parts and they can launch the virtual machines accordingly. AWS also uses some kind of hypervisor. Okay, so this was the concept of
So,
VM.
in in hypervisor concept, like OS operating system will be one, or like I didn't get it.
In
Like
host, look, look,
how we
look, let me
yeah.
tell you. In host, there
There
will
is
be
no
no
OS, right?
there is no OS basically. There is a very low
Okay.
level program that will be communicating with the hardware, which will be dividing your hardware into multiple subsections, right? So there will be no OS when it comes to the hypervisor. Okay, there will be a low level
Okay.
program that is hypervisor actually itself, which communicates with the system. Low level, what I mean by low level, that doesn't mean like the level of program is downgraded or something like that. Low level means that program is capable to communicate with the hardware. Okay, low level and high level, these are the terms that we use in the programming languages. High level programming languages are not able to communicate with the system or the hardware directly. They use multiple layers, like the communicating to the shell, that communicating the shell communicates to the kernel, that communicating to the hardware, right? And when it comes to the hypervisor, hypervisor directly works on the shell level or under the shell level, which can directly communicate to the kernel, and then kernel communicate to the hardware. And sometimes hypervisor have a very basic kernel, very low level kernel, which directly communicates with the. Okay, so that's why low level means nearest to hardware. Now, this concept is a virtual machine concept, right? Now we can do the similar deployment in this virtual machine concept, right? No issue will be there. We can do that. But again, when we talk about the point of view of the developers, so what happens in the development? What are the issues that developers face while deploying or creating an application? Whenever a developer will be developing an application, which is this huge application, which is divided into multiple components, there are many phases and many issues that may occur. The most of the very common issue which occurs in the development is that this code is working on my system. I don't know why it's not working in your system. You guys may have seen memes like this, right? So what it means, it works on my system. I don't know how it will work on your system. If it doesn't work on your system, I don't know. So it's a meme, but actually it's a big problem as well. Why? Because for example, you have developed a code, okay, and to develop that code, you have used few dependencies. Like for example, you guys remember we were trying to build the code yesterday, and the code was built on Java 8. We were trying to build on Java 11. We faced the error. That's the situation. Why the situation was there? Because the code was built on Java 8. So the requirement or the dependency was Java 8. But in our system, we don't have Java 8. We have Java 11. So we were not able to build the Java 8 code. So the same issue may occur with multiple people. Like what happens here, for example, there are basically multiple phases of developing a software. You guys remember software development life cycles? Okay, agile. What happens there? Agile is not only for DevOps; they also implement some process of developer and as well. where developer starts the development. After the development, the code is tested by the QA, right? But in our case, the code is being tested in the DevOps pipeline, but it's also tested before the build and the pipeline as well, in some cases. Now, if a developer has developed a code, and even if we are talking about the pipeline, the same pipeline that we discussed earlier, and the code is sent it to the QA. Now, the code was working on the developer system. Now, on the QA system, the code was not working because the Java version is completely different. So that's the issue. Now, Docker helps to overcome these issues. How? Because in the Docker, what you do, for example, I have written some code and you can understand the code like this. Like, for example, this is the code. Okay. What developer does, developer actually binds the code in an image. So this is an image, in an image. Okay. Now this image is sent to the QA or the testing team. Now what QA does, the QA launches the container using the same image. Now you guys must be wondering what this image contains or what is the content inside this image. Not only the code, all dependencies are also present here, like Java, any Maven dependency, everything will be already inside this image. Okay.
Can you talk more about the binding? I'm unaware of this concept.
Binding is nothing but, like, for example, I have a Docker image or I have an image, right? A low level image, or you can understand it like creating an environment. Okay, for example, I am creating an environment, okay, a separate environment where I am adding Java dependencies or more dependencies like Maven, the specific version of Java. For example, I'm using Java 8, 3.x version of Maven, right? And I have created image using this environment. I have converted this environment into a form or into an image. Uh, Consider it as an AMI for one time, right? The AMI that we are creating in the AWS, the image of the system. Now sending the same image to the QA. Now what QA will do? QA will launch the container or use the same image to test the code. Now what will happen? There will be no errors because we took the whole environment which was set it up on the developer end. So there will be no errors on the QA because there is no dependency issue. We directly took the whole image and we tested the whole image. So there are very less chances of the issues, right? Because we are using the same environment. Now this time, developer can't say like it's working on my system and it will not work in your. I don't know how it will work on the system. Why? Because we are sending the environment from here to there, directly whole environment. And the QA will be using the same environment, so there will be no errors. And again, the same image can be sent to the deployment level as well.
Okay, so talking from the CI/CD point of view, we are going to integrate the whole environment into the main pipeline.
Exactly, we can do that very easily.
Oh, okay. And one more question. Um, so before this image is created, where was the developer working exactly? Was he working on the hypervisor in a different virtual machine,
No, no,
which
look,
he
look, look.
then?
What the environment you are talking about, the developer's workstation, right? A
Yes.
workstation can be your own local system as well. It's not
Okay, and
necessarily
then
the
he
work.
just.
Yes, yes.
Okay, okay,
So my local system, for example, this is my local system. This is my workstation where I'm developing the code. And to develop the code, I'm using the environment. I'm creating a separate environment, or you can say workspace, like you guys usually do. What you guys do to, like, for example, you guys go on a trip, right? You took lots of photos. Now what you will do, you will create a folder, specific folder for that particular trip, and you will put all the images of that trip in that particular folder. It means creating a workspace for a special work, right? Similar like that, creating an environment to start your work on that particular project, as simple as this. Okay. So in this environment, we will not be like, it's not difficult part to create the environment. We will be using the Docker file to create the similar kind of stuff, where we will be providing all the details, and the same file will be sent to here and there. And also we can create the images from that file. I will let you know how to do all that things. Okay. So this is how the concept of Docker works. Now the same image will be sent to the deployment part, and again the same image can be deployed. I'm not talking about the production of that kind of thing. We are just talking about the deployment right now. Okay, build, like QA test and deploy. All things are done in the phase of images. Okay, now because we are using images, like apart from this environment, what else this image contains? Okay, number one, this image is nothing but it's a low level OS, you can say. I will not say whole OS, remember that, or you can say some part of OS. Why some part of OS? Because your OS may contain Java 17, but this image contains Java 8. So if you want to test anything inside the image has a separate environment, isolated environment where you can do the testing. Or if you guys know about the security points, like in our security points, what we do, like in the security trainings, what we usually do, we use the sandbox environment. You guys know about the sandbox environment?
No.
Okay, sandbox is basically, by the way, the term sandbox is used because if you guys know about the military trainings or any other training where they are testing the explosions, what they do, they throw the grenades or bombs in the area where there is lot of sand, because sand can, what we will say, adjust the heat, or like the fire will not come there, right? So to handle the blast and that kind of thing. So sandbox is basically an environment in which you will test your stuff. It's specifically an environment where you can do mess, where you can test your suspicious things as well. So it's also an isolated environment completely. For the security point of view, this isolated environment is not connected to any network. It's a completely isolated environment. But here, when we talk about the OS part, that means it's also the isolated one. Okay, and but we have the networking concept in Docker. We can create the networks as well, depending on our requirement. We will talk about that later, but for now it's nothing but it's a kind of small some part of OS, which actually is not a full OS or whole OS. Why? Because every OS has a main component, and the component name is kernel. Yeah, okay, do you guys know about the kernel? Anyone?
You explained it to us, right, last time?
Yes, yes.
Yeah,
So
the core of operating
exactly.
system.
Kernel is the core of operating system. Now the Docker does not have any kernel. The images, these images that we're talking about, this environment, there is no kernel in this environment. This environment actually uses the kernel of the host operating system. I'm talking about the differences between the VM and the Docker or the containerization. Okay, so this image can be considered as the Docker image. You guys can consider it as a Docker image, this environment, and this part is the VM. Now, when we talk about the VM, every VM has its own whole OS. Okay, whole OS. And here, when we talk about the images or the container images or Docker images, in the Docker images, there is no whole OS. Why? Because kernel is not present there. Even lots of stuff is missing from that image. Only the required stuff is there. Simple, basic required stuff. Few commands, few dependencies, few directory structure. That's it. Not the whole OS is there. That's why Docker images are very, very lightweight. So sending a Docker image from developer to QA will be very easy, even if the image is lightweight, because we can do the same thing with the VMs. What if, for example, me and Anurag are working on a project? Now I am a developer and Anurag is a QA. I develop something on AWS EC2 instance and I will create the AMI. I am sending the AMI to Anurag. Now Anurag will launch the AMI again, launch the instance and start its work, right? The size of AMI is very huge. It's not as small as the images. When you compare the size of VM images, like AMI is nothing but it's a, you can also understand it as a VM image as well at some point when we talk about VMs, because here the concept is on prime and AMI is the concept of public cloud, right? Now, why there is a size difference? Because just guess what can be the size of an Ubuntu operating system? Any guess?
Yeah, it's very big.
It's very
7
big.
to 8 GB.
Exactly. Maybe higher than 8 gigabytes, right? If you do some updates and install more softwares. But when it
Right.
comes to the Docker images, Initially, when we talk about the lowest image, like alpine images are the lightest images. The size is 4 megabytes, 5 megabytes. Now you guys can get the idea, the major
I
differences.
have a question. What is Docker doing differently that the whole requirement of operating system is removed?
Like it's using the components of base operating system to do its work.
Okay, so only the bare essentials for getting the job done.
Exactly. Only
Okay,
dependencies and few commands are inside the image. Rest of the stuff is being used from the host operating system. That's why it's very lightweight,
right.
and you can send this image to any other operating system as well. It will work over there as well. But remember, when it comes to the cross-platform, Docker is not compatible in that case. Cross-platform means the image create for the like where you have when you are working with the Ubuntu image, right? Ubuntu container, Linux container. You can launch the Linux containers on Windows systems. We can do that in this Windows system. But when it comes to the Linux system, you cannot launch Windows containers in Linux system, because when it comes to the kernel or the low level part, in Windows, we have the subsystem concept where we can use the Linux components or Linux stuff in Windows. But when it comes to the Linux, Linux does not supports Windows concept, right? There is no window kernel support or something like that over there. So that's the major issue. Remember that. So you cannot launch Windows container in Linux systems. You can launch Windows containers only Windows systems. Yeah, you can launch the Windows containers as well. This is also possible. The containers are not limited to the you will say like Alpine or that kind of thing. You can launch the Ubuntu containers, you can launch the CentOS containers, you can launch the Windows containers as well. But at the 99%, 99.99% of your whole life, you're not going to use the Windows containers. There are very, very rare organizations which are using the Windows containers, and even I don't know why they are using the Windows containers. Because when it comes to the Windows operating system and you are using containerization and even you are launching the Windows container, that's a whole mess and stupid work, basically. Because containers are meant to be for lightweight work, and Windows is a very, very heavy operating system as compared to the Linux. That's why I said this. Okay. So, the conclusion is that when we talk about the difference between the Docker images or containers and the VMs, VMs are heavy in weight, like that means the size will be high. And when we talk about the images, the size will be very low. And the occupancy, like VM will occupy more resources as compared to images, right? Images can be executed or used in single operating system, but VM will require more huge RAM, infra, and that kind of stuff because the whole operating system will be running. And here, the only container is running with few dependencies and few application stuff. So this is the major difference and the use cases of containerization. Now, for this containerization technology, now it's a technology. Containerization is a technology. Okay, we have multiple applications which provide us the facility of this containerization technology. Docker is one of them. We also have multiple applications like multiple popular tools like Docker. Container D is also there. I guess Container D is the tool, another tool which is similar to Docker. And also there are a few more tools in the market, but the Docker is the popular one that we use in day-to-day life. Like I use Docker in my day-to-day life, and you guys will be using the Docker as well at the most of the cases. Now, what actually Docker is doing here? Because when we talked about the images, we talked about the containers. Now, remember, I talked about two different things. Number one is image, number two is container. You guys can understand it like image is not a running thing. Image is a kind of backup, and container is a running instance or running stuff, which is continuously running. Okay, so these two are different things. And how you guys can visualize the container, let me show you the image of Docker so that you guys can get the idea of Docker. So basically this is Docker, and you can see it's similar to ship and whale kind of thing, right? The fish is there, and over this fish there are a few containers. So the containers that are present on the harbor, basically those containers. This is the image of that particular Docker. And you guys can go through this website. You will see lots of stuff there. Okay. Also, the blogs are there. And if you want to learn Docker documentation, docs, you can say, search for docs as well. Here is the Docker documentation. Here you can learn about the Docker. Lots of stuff is there. Manual, installation, get started, everything is present here, right? And I will suggest you guys to go through the whole process of Docker, like containerization, images, what is container image, everything is present here. Okay, and you will see more information here as well. So again, it's a kind of open source stuff. Okay, and you guys can go through everything. Yeah, it's open source, and you guys can go through to the docs as well. Similar to Jenkins, you guys can go through the docs. Jenkins also has docs. You guys can go through those docs as well. Now, container and image both are separate thing. As I told you, image is nothing but it's the backup, or you can say stopped stuff, and container is the running instance or running entity, you can say, where the application is actually running and functional. And Docker is nothing but it's a tool which is communicating with the container, the images, which is providing you the facility of images, containers, and maintaining whole stuff. Also, these containers have some networking, right? Networking means if you want to launch two containers and you want that these two containers should be able to talk to each other. You can also do that, right? Docker has the concept of networking. Few networking components are there, like bridge connection, host only connection. Bridge is the default one, where you can access the internet inside the containers as well. Then we have net connection, and the host connection is also there. Overlay network is also there. So you guys can go through that Docker network concept as well. It's a very good thing to learn. Okay. Now let's directly jump to the Docker usage. Okay. So right now, today I'm not using the AWS. Okay. What I'm doing here is I'm using this virtual machine that I have set it up here. And actually, I don't prefer the UI because I cannot directly copy and paste stuff from the browser directly here. So what I did, I set it up the virtual machine here, and I launched this virtual machine in a bridge connection. Bridge means currently this virtual machine is acting as a independent machine in my home network. So using that, I took SSH into that virtual machine. So this is the virtual machine, and I'm using this virtual machine through the SSH right from here, the my subsystem of Linux. Now in this subsystem, I can directly do the copy and paste. That's why I'm using this here. Okay, so don't worry about that. It's nothing too different thing. I'm just taking SSH on the same machine which is present on my system. We can do that very easily. Okay, now this is the console of this virtual machine, and here I can do the same thing that we did on the AWS. The only difference is that I have 4 gigabytes of RAM here, 4 core CPUs. So that's a powerful machine as compared to the AWS instances right now. Okay, because in AWS we have to pay a lot for those instances. Now Jenkins is also set it up on the same machine. Okay, so this is the Jenkins IP where you guys can see Jenkins. But before we go to the Jenkins, let me show you the Docker. So Docker is already installed here. If you guys run this Docker command, hit enter, you will see all the details of Docker. Like all the options of Docker commands are here. Okay. And if you want to run anything, you guys can directly do that. Like Docker run hello. And I guess it's hyphen or something like that. Let me check. Let's click on Docker docs, download installation. Just click for the Linux. Actually, I have done the installation. The whole installation part is here. I'm just checking out the first image that they show in this concept. Debian. I'm just looking for the Docker Hello World, Docker version, Docker desktop. No. Let me select the Ubuntu here. In Ubuntu, we may see something related to Docker Hello World. They are talking about Docker desktop again and again. We don't want the Docker desktop. We just want the image where we can test the Docker, right? So seems like they haven't shown the image here. Let me search for the hello world. Okay, maybe it's not here. Here it is. So Docker run hello world. If you just hit enter, it says unable to find image hello world locally. Now what's happening here? Okay, let me show you. Unable to find image locally. First of all, it will check for the image in your local system. If it is available, not available, it will pull the image. Pulling the image means taking out the image, downloading the image from the Docker Hub. Now, Docker Hub is nothing but, you can say it's an artifactory or it's a Docker registry. The public Docker registry is Docker Hub. Now, you guys must be wondering from where we will get the images. Docker Hub is the place where you can get the public images. Okay. For example, I want the image of Nginx to launch the Nginx container. I can get it from Docker Hub. Here are the free official image, and all the images are completely free. You want to use the Nginx image? Just copy this and paste it here. Not like this. Copy done. Control C. Clear. Let me try the paste command. Okay, it's not working right now. I guess shift insert works here. Not shift insert. Control V is working. No, Control Shift V. Yeah, Control Shift V is working here. So yeah, we have some separate commands in here and there. So Docker pull Nginx. If you just hit enter, it will pull the latest image of Nginx. As you can see, that means it's downloading the Nginx image from this Docker Hub. Now latest means the tag is latest. Means it will pick the latest version of Nginx. If you guys want to use the any older version of Nginx, you guys can do that. Just click on tags, and here you guys can see the tags, okay, which shows about the version. And in the overview, you guys can also check about the version, okay, about the images, how to run the image, and multiple commands related to the image are present here. You guys can go through the commands as well. So whenever you are going to use any image, okay, for example, any public image, you don't know about how to use that image and what are the configurations which are already done. Because what happens, like for example, I'm using Nginx image, right? You guys know, I know that Nginx has few configurations. The configuration file is there, lots of stuff is there. So is there any change inside this image, or it's a stock image? Like stock means by default everything that we get in our system while we install Nginx. Is it the same as that stock Nginx, or there are some changes? So you guys can check out those stuff here. If there is any change, you guys can check out the commands that you guys can use in that particular Nginx. Okay. So I think you guys got the idea of Nginx concept, the image concept, like pulling the image from the Docker Hub. Now, as you can see, we got the image from Docker Hub. Now it says we have the image pulling the image done, downloading image done. Okay, just clear the screen, and here's a command called Docker images. If you just hit enter, you will see all the images present in your local system. We have two images. Number one is Nginx, and second one is Hello World. Okay, hello is little bit cut it out. Yeah, is Hello World. Now you guys must be wondering, it says created 2 weeks ago and 14 months ago, right? First of all, this is the image, these are the tags, these are the image ID. Now created, when the images were created. So the Nginx image was created 2 weeks ago because we downloaded the latest Nginx, and the Hello World image was created 14 months ago. This is the size of Nginx image. It's 142 MB, still less than an operating system, right? And the size of Hello World image is only 13.3 KB. Even I don't think that there will be some low level operating system in this Hello World image. Only text should be there, right? So this is how images looks like. Now we cannot use this image, right? Like we cannot get into this image. How we can use this image? We have to launch the container using this image. So let's launch the container using this same image. So how we can launch the container? Docker run is the command to launch the container. And after Docker run, use double hyphen name to provide the name to your container. My Nginx. This is the name that I am going to give to my container. Now container is the running entity. Okay, remember that. Then we have to do the port mapping. Why port mapping is required? Because Nginx is a web server. Okay. Whenever you guys use the Nginx, by default it works on port 80. Remember that? We tested the Nginx by using the IP address and it was working on the port 80, right? So I'm going to
Yes.
I'm going to do the port mapping here. Now, what is actually is port mapping? Because container is also an environment which also has few firewall system like the ports and that stuff. And we are also using a host operating system, which also is a separate operating system. Okay, so we are binding the we are communicate binding the port of your container with your operating system. Okay, now the port inside the container will be 80. Why? Because it's the Nginx container. By default it will be 80 till I do any change inside the configuration file of Nginx. But here I'm just directly going to run this container, so it will be 80. Now after the colon I have to provide the port number of the system. So what it will be, let's select 80 as well, right? 80 colon 80 space. Now here we have to give the name of the image and the ending. You guys can use multiple options here as well. Right now I'm just only using these options and hit enter. And what it says, started worker process this. These are the logs of Nginx, right? Now how we can test that this container is working or not? Because I have mapped this 80 to 80, that means I will be able to access the Nginx page directly with the IP of the virtual machine. Okay, so http colon double slash IP address, hit enter, and we got the Nginx page. Now this Nginx page is directly coming from the Docker container. Okay, it's not hosted on my system, on my VM. It's coming from the container. This is how image looks like. And let's do some testing as well. First of all, I'm just stopping this doing exit from the container. And if I do the refresh, let's see what happens. It stopped working. Why? Because I just pressed Control C and I exited from the container and Nginx is also stopped because I used the Control C. Now, when I use this command, I use the Control C and the Nginx stopped and we got out from the container. Now, how we can check the container that we just launched, right? Docker PS will show you all the running process of Docker. If you hit enter, as you can see, it shows the Docker container ID, image number, image ID or image name will be the image name will be here. I guess yeah, image name will be here or image ID, but we will check that. Commands that we used to run the container, we didn't use any command by the way. Created, status, ports, and names. And you can see there is no container listed here because our container is not running right now. It stopped. That's why we got this error, right? Unable to connect. Now, if you want to see your container which is stopped, you have to use -a flag here. So docker ps-a, hit enter, you will see your container here. We launched two containers. First was the hello world, and the second one is this. Uh, just a second. Actually, my phone is discharged. Okay. So the first one is the Nginx. No, the first one is the hello world that we started earlier. This was the name of the image, and this is the container ID. Okay. And the first one, the last one that we just launched recently is Nginx. As you can see, created about 1 minute ago, exited 1 minute ago. Now, if we want to use the same container again, no need to use the run command now. Why? Because we have executed or launched the container using the image. Now we just need to start the container. So we have a command called docker start nginx. Hit enter. Now it says failed to start Docker container. Why? Because we didn't started that container with the separate mode, detached mode. We started it with the attached mode, right? That's why we are facing this issue. Now let's again docker ps-a and docker rm means remove, and then we have to give the name my nginx. That's it. Now if you do this docker ps-a, my nginx container is removed now. Okay, so what I'm going to do is I'm going to launch the same container, but this time I'm going to use few more options like -itd, interactive and detached mode. Hit enter. That's it. And this is the whole container ID. If you just do docker ps here, you guys will see nginx container is in running state. I haven't used the ps hyphen a, still in the running state. Why it's keep running? Because I have used this d for detach. I is for basically interactive, and t is for the tty terminal, basically inside the container. And d is for detach. Detach means there is no need to keep that container logs running in the foreground in the main screen. It will keep running in the background. Okay, so if you just do docker ps here, hit enter, as you can see it's still running on port this. If you just do the refresh, you will see nginx is present here, right? So this is how you can launch the containers using docker image or using docker. You guys got the concept?
Yes.
Now, because we have this container launched, and if I want to do any change inside the container, how I can do that? I can get into this container because it's a separate environment, and we can change the content of this welcome nginx as well. It's just up to us. Okay. So how we can do that? Let's use the docker exec command. Exec means execute. Okay. Hyphen it for the interactive, and terminal. T stands for terminal, TTY basically, and I for interactive. We want the terminal, right? That's why we are using this. Not D this time. We want it in the attached mode. That's how we will be able to send commands inside the container. And the name of the container. The name of the container is my nginx. GINX, yeah, the name is correct. After this, I have to provide the shell name that I want to take inside the container, and that's the bin bash. I want to use the bash shell, or I will just say execute this. The meaning of this command is executing this command, this bash shell, inside the container and giving me the terminal, TTY. Let's hit enter. And as you can see, here was master, host name is master, and here we have some ID. That means we are inside the container right now. This is a new environment, which is basically the Docker environment that we are using right now. Okay, the inside the container. Right now we are inside the container in a separate environment. Let's go to the etc nginx. Here we have all the details, config.de and that kind of stuff, where in the where we have something. Let's check about the check for the html file, right? So let's keep in this and cd config.d default.config. Let's check this configuration file. Let's see the page. So here is the page, usr share nginx.html. This is the path. Let's open this. Vim will not be there, by the way. Let's echo hi from docker and redirect this into /usr /share nginx html and index.html. Hit enter. Let me refresh this. As you can see, hi from docker, right? We did the same thing, but going inside the container. You can also do that outside from the container. You can start the container by passing some commands as well. Now let's exit from the container. Now as you can see, I am again on the master. That means I am back to the virtual machine. Now I am out from the container. But container is still running. If you do the docker ps, it's still running. We just exited that session that we created using the bin bash or itd, right? This is how you guys can use the containers. Okay, you guys got it? Yes or no?
Yes.
And for using the same thing in the nginx, we can easily do that. First of all, let me just do the docker stop my nginx. This command is used to stop the container, and docker rm my nginx. Now let me check this path. Okay, so this is the path, right? Rm my nginx. Okay, let's go to the Jenkins and create a pipeline now. Okay, new item. Let me log into the Jenkins. and I'm going to create a pipeline which is for Docker pipeline. Let's create a pipeline. Okay, so description Docker test pipeline. Okay, if you have a GitHub repo, you guys can select the GitHub repo here from here as well. Where it is GitHub project. Okay, you can use the GitHub URL here. But right now, I'm not using anything here. I'm just directly going with the Jenkins pipeline here. So I need some sample code so that I can write it, and I will click here, try sample pipeline. No, hello world. So you guys can see I got the sample structure here directly when I clicked on hello world. And in this stages, I will create more stages here. So this is the steps and this is the stage. All right, I'm going to copy the stage, hit enter, one more stage for the deploy. One more stage for the deploy, build and deploy. All right. And let me give the name to this stage as build and the name of the another stage as deploy, where we will be launching the container. Okay, so in the build, what you can do is you guys can build the Docker image, right? So how we can build the Docker image, let me show you another concept today. Okay, so we can also create a Docker file. Now Docker file is nothing but it's a file in which you can write the instructions to create an image. Okay, so if I have created one Docker file here. This is a Docker file where I'm just performing this, but I will not do this. What I will do is run, and what I will run here is echo hi from Jenkins, and I will redirect it in /usr share nginx. I'm not sure about the path. Let me check the path first. Missed that path. Let me check here. Here it is. Okay, as you guys can see, we have some information here as well. So I was looking for this path where the index.html is present, right? So that I can put the exact content in that inside that. Okay, so hire from nginx and send it to index.html inside this. Okay, so we are doing nothing but we are just echoing this hi from Jenkins inside this HTML file. And as you can see, I have used there two, you can say, what we will say, commands here. The number one is from command. Okay, using from, you can give the name of the image, like from which image you are going to create another image. That means to create an image, you can use one base image as well. So for this task, I am using Nginx image as my base image. So what will happen? I will create another image using this Nginx image, and inside that image, this task will be executed. Okay, by default, when I will create the image, this task will be executed. Okay, and to create the image, we have a command called docker build. Build command is used to build the images using Docker files. This is a Docker file. This is how it looks. Sorry. This is the looking of Docker file. Now the line of code inside the Docker file can be huge. Like it's not only 2 or 3 lines. You can create multi-line, multi-stage Docker files. It's a huge concept. So you guys can check the documentation for the Docker file as well. Again, it's a practice work where you can do that. But this is the basic looking. First, I'm using from to define the base image. Like I'm going to use the Nginx image to build my image, and I'm going to execute this command inside that image. I hope you guys got it. Hit enter, the file is ready. Okay, now I have to provide the path as well. This is the path. Okay, so let me place this file somewhere else, because the Jenkins is going to execute this file using Jenkins user ID Jenkins. Yeah, it's going to execute this path using Jenkins user. So it will be difficult for Jenkins user to execute this file. So what I'm going to do here is I'm going to move this Docker folder from here to slash var lib Jenkins, so that will become easy to manage by Jenkins. And inside this, I have to change the permission as well, because I have created this by root hyphen r Jenkins colon Jenkins, and the name of the container is Docker. Name of the file is Docker. Sorry, the what we will say, name of this particular directory is Docker. Okay, so this is the Docker file that we are going to use, and let's go back here. pwd is required because we are going to create the job for the build process as well. Okay, the data is copied here. Let's go to this place. Now this is the path. So the first command is to build the Docker project. Okay, Docker build hyphen t to provide the tag, and no. Let me first copy the file on the same location. That will be great to manage. cp slash docker file. Let me check here the name. Docker file. Yeah. Okay. Where I'm copying this file? Dot slash. Now, after copying it inside the dot slash, I'm using the command. What command? Yeah. Docker build hyphen t my image. Okay, docker build hyphen t my image and dot for the, that means the Docker file is already present here. Now as you guys can see, there's some issue in the syntax, so I'm just using triple exclamation marks so that it can go whole green. Now this will be working fine. Okay, there will be no issue in executing this command. Docker cp, first of all we will be copying this Docker file into the same directory, then we will be using this command docker build hyphen t my image and dot, that means the Docker file. Okay, after building the image, in the deploy part we want to deploy this nginx, right? So again we need to use the sh here, triple so that we can use the multi-line commands here. Now, because the image is built here, docker run hyphen itd, the first thing is that to provide the interactive tty and detach hyphen name equals to my what we will see, doc my doc. It's a good name. After providing the name, we have to provide the port hyphen p 80 colon 80, the port mapping. In the ending, we have to provide the image name, right? Nothing else. My image that will be going to be created from here, not nginx this time. Why? Because we are creating a separate image which is our own image in the build process, so we are going to use that image only here, right? After this, if you want to do the test here as well, to do the health check, you guys can also do that by adding one more stage. Right now I guess this will work fine for us. Okay, and yeah, that's it. We created this Jenkins pipeline. If you guys have any doubt in this Jenkins code, you guys can ask. Then I will save
Yeah.
this and execute the pipeline.
So first time when you make a Docker file, you didn't build a image. So image will build here, right?
Exactly. Last time when I created the Docker file, I was trying to do something else. I was not planning for the build process actually.
Okay, the same content will be in that Docker file, which is going to build a image in second step, and the third step it is going to run that image, right?
Exactly. Deployment. It's a kind of deployment that is going to be done on same server right now.
Yeah.
Okay. So I'm just saving this pipeline. Seems like everything will work fine. Let's build it now. Unable to connect. Why? Is there any issue with the Jenkins? Jenkins got crashed. Oh shit. You guys are able to hear me? Hello? Using the Wi-Fi for the IP. So that's why it also disconnected. And as you can see, there was some failure from the build and it says permission denied. Okay. So yeah, we were not able to see the error. Yeah, recording is resumed. Okay. You guys can hear me properly, right? And screen is also visible, right? Hello.
Yes, we can see your screen.
Okay. All right. So right now, as you can see, we got some error, and the error says that got permission denied while trying to connect with the Docker daemon socket. Now, this error says that we cannot use the Docker directly using the normal user. It will work with the master user. So we have a specific fix for that. That's your task to fix this. Okay. But right now, I will use this with the sudo. Okay, to run this job. But we can do that for a fix. Like you guys will face the same issue because Docker command will not work without the sudo. Initially, you have to do a fix for this. Okay, you guys will look for the fix. Right now, I'm just executing this with this sudo command and I'm just good to go. Let's build it now. Okay, so another build. Let's see what's the error now. It says sudo this. A terminal is required to read the password. Oh, forget that. The sudo is also not provided to the system. So let's do sh and let me give the sudo permission to this Jenkins user. Okay. So if you guys don't know how to give the sudo permission to a user, this is the way. Just go into the sudoers file, do the entry exactly here. Okay. Insert Jenkins tab all equals to all colon all. Just after this, we have to type something which says no password. Let me check if the syntax is written somewhere else. Not written. No password colon all. I guess this should work. Su Jenkins sudo ls. It's working fine now. Okay. I did nothing. I just gave the permission of the sudo without password to Jenkins. Like Jenkins can use the sudo without giving the password. Again, let's run the pipeline. So this is what happens whenever you're going to run the pipeline or creating job for the first time. Okay, as you can see, build worked perfectly. And the job is success this time, right? We got the success now. So first of all, the job is succeed because by the way, so VM is very fast as compared to the instance. This is the build process. This is the deployment process. If you want to see the separate logs, you guys can click here and see the logs, right? But the good approach is that click on this checkbox where you can see the console output. That means what will be happening in the background, you can see directly from here. So first of all, this is the workspace of Jenkins, okay, running on the Jenkins inside this. Now here, first command was cp command to copy the Docker file on the same path, dot slash. After this, we executed this build command to create the Docker image, which is the my image. Inside this build command, the steps worked. These steps were written in our Docker file from Nginx latest run echo hello hi to this path, right? You guys remember this? Just after this, our image was built and the name of the image was my image. After this, we use this command to run this on port 8080. Now, because we got the success, that means it should work on the port 80, right? Now here we have hi from Docker. It's the old output. And here we passed hi from Jenkins. Let's refresh the page. And we got hi from Jenkins. That means our build and deploy using Docker is done successfully. So CI/CD with Docker is done here. If you guys have any doubts, you guys can ask. Any doubts?
None from my side.
Okay, Adarsh.
And from my end as well, Manish.
Okay, so means you all are clear with Docker, right? And the Jenkins as well. So your
Not
task is to,
uh, it's little tricky. Maybe we'll go through the so many things you did. It will take time maybe to understand.
yeah, it will take time because the only thing it takes is practice. Even in the beginning, I am not able to do that. Even I create the CI/CD jobs in my day-to-day life for the production as well, and this is a very common thing that for 1 to 2 times you will face the issue because nobody can expect that they will forget to type the sudo there. Because I was hoping because on my all system I use Docker because sudo is already there. The fix is already there. That's why I didn't get this error. So this was unexpected initially. Second time when I give the sudo, I forget that I am giving sudo, but Jenkins user doesn't have the sudo power. So again got the error, again did the fix, like give the power of the sudo to the Jenkins so that it can do the sudo directly without password. So it fixed, and in the ending, like all the fixes are done, so we got the success stages. So if you get these errors, that means you are going to learn new thing. Okay, these are the Linux debugging process that you are going to face many times. Okay, all right, guys, that's all for today. I will be sharing the recording on the drive. You guys can check out the recording from there, and you can also post your doubts on that particular classroom comment section. Okay, whenever I get free, I will update the solutions over there. Also, the installation process URL is on the classroom as well. You guys can get the installation process uh, from a URL from there and start doing your installation of the Docker, and you guys can start work on the Docker. And again, your task is to fix this error directly. Let me elaborate the task more. By default, whenever you will be installing the Docker, Docker will only work with the root user or sudo command. Your task is to use the Docker without sudo or the root user. Okay, that's your task, to use the Docker without sudo or the root user by with just a normal regular user. Okay, got it? Guys, got it?
Yes.
Yeah, Manish.
Yes.
All right
Thank you,
then.
Manish.
Goodbye.
Thank you.